Thank you. Inga mana, inga reo, inga iwi, e rau rangatira mā, tēnā koutou, tēnā koutou, tēnā koutou katoa. Hello everyone and welcome to my presentation, which will cover topography at LINZ today. Sorry. I'll start off with a very brief history for the topographic map products. Sorry, I've just got to get rid of an extra screen here. A brief history of topo map production at LINZ, showing you where we've come from, and then tell you about some of the work that we're currently undertaking, and then finishing off with what our next immediate steps will be. I would like to tell everyone about our modified logo. So government departments in New Zealand are changing the prominence of their Māori names by putting them first. Our name is part of a well-known proverb, which is Whatu Ngāo Ngāo Te Tangata Toitū Te Whenua. And this translates to people come and go, but the land remains. And in this context, the land includes water, air, and everything else on, above, and below the earth. We will still refer to LINZ as an abbreviation and a non-formal version of our name. And just a quick word from our sponsors, and this has been recorded, so I won't go through it. You can just pause it later. And our outcomes are listed here, and topography fits mainly into outcome 1. The changing nature of our work means that we're sometimes called into other areas, and we assist as subject matter experts and advise where we can. So today topography consists of about 20 staff, and we're placed within the location information group, and that has around 100 staff, and that includes hydrography, positioning and resilience, and addressing and property, and data services, and a couple more. But of course, it hasn't always been that way. So going back in time, we started towards making our topographic map series in 1931, and you can see from the notes here that we've been using Air Force photography, and we had always used the latest and the best technology that money could buy to make these maps. So in 1939, the first NZMS1 was created using methods that lasted for over 40 years. But the NZMS1 map series was actually never completed. In the mid-70s, the new NZMS 260 series was started. This was completed as a series in the mid-90s, and that's when I joined the photogrammetric branch at Heaphy House in Wellington Central. And at this time, all the work relating to the creation and the maintenance was completed in-house, but by separated and distinct business units. So this started with our surveyors creating ground control, flight planning, aerial triangulation, photogrammetry, cartography, field checking, map printing, and sales. And alone there were 100 staff in photogram, and I think a few more in cartographic branch, and we captured everything in 3D. So when LINZ was created about 25 years ago, the maintenance was then completed by external private companies, and these contracts were managed by LINZ. So here in 2009, we have a very happy Minister for Land Information releasing the New Zealand Topo50 Map series, and by this time the maintenance for the map sheets has actually returned to be fully in-house again. And our map production system, as we mentioned in the introduction, is almost the same as it was then. And here's a slide from 2011, and it talks about how many maps we were actually producing and selling. So at the time, we were doing 2 types of updates. A fully maintained sheet was almost a recapture, and it took anything from a month to a year, while selected updates concentrated on the change only. And these can take anything from a few days to a week or 2. And the digital data and paper versions were actually out of sync. And this is something that we thought was a good idea at the time, but our customers weren't really ready for. And we reverted back to releasing our printed map products and our digital data at exactly the same time. So these are our 3 main delivery channels that we have today. So our maps are sold from the warehouse. Our map chooser is accessible from our main LINZ website and the LINZ data service. So you compare these numbers with today and 10 years later, and our paper map sales are still very consistent. And you can see the effects of the level 4 lockdown that we had in New Zealand last year and how we've tracked after that. So we've sort of gone to levels that we've never seen before with both our map chooser and our paper sales are certainly well up there. But what this does hide is the fact there's a digital and direct usage of maps from within applications, as well as the fact that Defence Forces do their own printing for map exercises now. So those numbers would normally be in those paper map sales. And our customer feedback also shows that some people simply have a screen grab of an image of a map before they go out and take it with them on their devices when they're out tramping. So these statistics here are from our LINZ data service, showing the changing nature of our digital delivery environment. We still get more new users, we have more page views, and now we're getting 15 million API calls rather than the 3 million web service requests that we had in the past. And we have really good information about the layers and services that are being used. We annually send out satisfaction surveys, and we actually have ministerial targets to achieve with customer satisfaction ratings. So hopefully the previous section has shown you the reason we need to keep changing is because topographic map data is still very relevant in Aotearoa, and the use of data is more widespread than ever and is continuing to grow. People expect accurate current data, but the person effort that we can apply to collecting and updating this information is more limited than it ever was before. So now I'll talk about some of the changes that have been made more recently. I will point out that each year LINZ runs a summer photo competition for staff, and I've used some of the images in this presentation. And there are some Lidar and map images that the Topographic team have created. So in 2016, our plan was to look at all our layers and identify which ones are provided by other sources. We focus on areas that would give us the greatest improvement benefit, and it followed on from our 10-year strategy document that was released in 2015. So the benefits that we're wanting to see are saving time on maintenance and providing more valuable information in our products. So right now we have a list of improvements that we call small wins and big rocks. So a small win example, we're now taking Transpower structure and line networks from their public portal and automatically identifying change. This data is then extracted and assigned as a task to update the topographic database. Because we actually make the code, we can take out any known issues that were found in the data previously, and we can run the tool at any time. And it also shows us if we've accidentally removed any data from our database. Something to note here is the comparison is on the data that's published on the LDS, and we don't go directly into the topo database. We have a few big rocks, and they tend to take up most of our time, and I'll talk about two different processes that we've made in the next few slides. So one of the big rocks is an improved road and track network. We believe that our positional accuracy was the first thing that we should fix, and in 2016 we started a 5-year capture program that has just recently been completed. So now we're getting within plus or minus 2 meters of the road center line when previously stated our plus or 22 meter accuracy for our map data. Our feeling is that we're getting value for money from our external service providers, and we've developed bespoke open source tools to help our new QA and data import flows. And these tools help us make sure that we're not losing any quality in the data that we already have. We found it really hard to create a specification for external capture because of the complexity of the work. And our approach was to review what we've done each year and then add or change for the next round of capture. And I don't believe that we actually have a great set of specifications yet, even after that time. So with the new QA roles and tools, we've made many small but significant improvements. So we reused the name and the road name ID from the cadastral road, and this means that topography don't need to try and maintain another record. So one cool function in our tools is the ability to send an email to the addressing team automatically from our GIS desktop tool on completion of a sheet QA. So the email can contain any road information problems that were found during our QA process. And because the addressing team already has a communication channel with the local councils, we get a reply back within a week, and then both the cadastral and the topographic record is fixed. So after the first few years, we found that our ability to recapture track information was very limited and difficult. And so we actually dropped that from the requirement from the specification because we knew that we could do a better job using LiDAR in the future. So another big rock was the creation of our building outline layers. This was created as an independent data set, and more information on this layer can be found on our Medium on location blog. So as well as the new layers, we've also created a process to generalize and create the Topo50 map data. So that's taking the task away from the Topo50 cartographers to update the buildings and providing more valuable information to the public. So one issue that we had there was that the project captures all the buildings by regional aerial imagery capture. So therefore it's actually out of sync with Topo50 data that is released by the sheet extents. But they do serve different purposes and they will align in the near future. And we believe that the benefit of having the data out there was more important, and we try to mitigate the risk of any misuse. So similar to the roads, we created in-house software to help us with this, and they include things like building editing tools to help us quickly fix any issues that we find. So the plan for the building outlines was always to start with a simple outline and then add attribution once we had the country captured. So as part of the government's response to COVID, we added a couple of new building types to this data and plan to add more in the future. And we've also purchased a facilities lab from a private company, and we're now including some of those types into our building outline layer. So how have we done? The bar graph on the left-hand side shows the release date of the current Topo50 sheets, and you can see most of our stock is under 3 years old, while we also have sheets that have never been changed. And the GIF on the right is our production for the last 12 months. But it's not just about the numbers, it's also about the quality and the impact. So we've covered our topographic data products and topographic data teamwork in the last section. So now I'll briefly talk about our partnership programs, and you can check out what we're up to by searching Elevation Aotearoa. This information has been presented quite a few times, and I'm sort of conscious of the time we're taking here. So I'll just quickly go through the next few slides. But our main reason of what we wanted to do this is because the way that we used to be funded meant that in all of New Zealand imagery appeared unattainable, where in full LIDAR coverage was only a dream. But thanks to the help of a wider LINZ team, we've managed to secure funding under the previous government's Provincial Growth Fund. So we're working with our partners to create QA processes, and everyone's really excited about the opportunities that this data will unlock. And we're also building more capability in-house to make sure that we can process and deliver any of the data really quickly. And within topography, we'll be using the LiDAR to help us improve our forestry roads and tracks, the work that we dropped off previously. But we haven't actually developed any tools to capture from LiDAR, and we've been waiting until our LiDAR capture program got underway and started delivering information before we started looking into this. So internationally, this is not new, and we feel that we can leverage off what others have done in this space. So to help with education, our team has created online tutorials so that people can actually create their own style backdrops. This is cool to me because, you know, shadows and aerial imagery are bad for data capture, but they're good for representing relief on maps. And stating the obvious is having this LiDAR is going to make a big improvement to how we're actually capturing information for our topo maps. So now we're looking into our immediate future. So the topography staff have been involved in the development of the LINZ base map service that was released last year. So our first map was an aerial and satellite imagery layer, and this has been a huge success story for us. So speed was our main target with this product, and using cloud computing, we can actually regenerate our cache within a few hours. And we're really focusing on web-based customers and making these services available to people who wouldn't otherwise have access to these maps. On the cloud point of view, the costs that we're incurring are well under our original estimates, and everything that we've created is also available on GitHub. So part of the loading process is to create cloud optimized geotiffs in a spatial temporal asset catalog. And this is to make sure that we can find, understand, and reuse the images in the cloud for the future. So assigning API keys means that we can easily see what applications are using our services, and we have the tools to monitor that usage. And we've already identified misuse, and this was just an innocent mistake by a customer, incurred a little bit of a cost for us, but we got hold of them and we actually offered them a different solution. As I mentioned, the public response to this has been great, and we're constantly seeing an increase in how many people are using the service. And I'll just quickly skip through to the next. So our vector tile service is about to be released to a small set of customers, and we plan on doing a full release later in the year. So while our first service is a topo-like map, having these services running means that we can start to create new map services that support the public in the future. And this is a really exciting time because we can now start to apply more modern cartographic styles to our maps. as well as serve different combinations of data. So we're doing topographic, hydrographic, cadastral, and derived. So community engagement has always been a big part of our role. And in the past, we had district offices around the country and people could just rock up and talk to us about anything map related. You know, people had direct access to local experts. And so while that access is still there, it's not very well publicized or widely known. So LINZ are very involved in education and knowledge sharing, and we reach out to novices as well as experts. Now it's not just about making and delivering maps and data, it's also about making sure that everyone has a fair access and is using them to their full potential. So educating people in cartography is something that we're driving within LINZ. So in topography, we use many people across a wide variety of tasks, and we're constantly training new people to do old and new processes. And staff are sometimes completing tasks infrequently and might not completely be sure about what is required. So to help with these situations, we're making sure what we do is well documented and that the documentation can take multiple formats. Each year, LINZ is also involved in virtual field trips run by Core Education, and this is to promote spatial sciences as possible career paths for students. So last year, I was out for 3 days with the Mountain Safety Council, Search and Rescue New Zealand, and the police making videos to show 11 and 12-year-olds how to get outdoors safely. The benefit for me was actually talking to professionals and volunteers who use our maps in their daily work, and we're using those insights to direct us with our future work. And finally, something cool that the manager of topographic products found while on vacation in Queenstown, our map printed on aluminium. So this has given me the answer to the repeated question, when are you going to stop making paper maps? And that is once the price of aluminium drops under $1,000 per tonne, and hopefully that will never happen. So thank you all very much for taking the time to listen to this presentation. I hope you all found out something new about Toitū Te Whenua and topography today. Ka kite anō au ia koutou.